We're going to spend time learning about switches and how a switch can be an input to a computer. The first switch that we'll look at is a momentary switch. In our case, we're using a momentary button, but it's essentially the same thing. The way that this type of switch works is that when you press the button, the switch goes into the closed condition. You have to maintain pressing the button to keep it in the closed position. As soon as you release the button, the switch will go into the open position. This is the button that we will be using to demonstrate a momentary switch and its input to a computer. This button is connected to a PCB, and we can see there are several resistors and LEDs on the board. The connection to the button is done through the white connector here on the left, and we have three different pins on that white connector: S, V, and G. S is for signal. This is the signal that we will be sending to the computer. V is the VCC, or the input power for the computer, and then G is for the ground connection. Now that we've seen the component, let's look at the corresponding wiring diagrams. I have two diagrams here. The top one shows the momentary button in the off position or released position, and the bottom schematic or diagram shows the button in the pressed position or on position. Each of these diagrams have the corresponding pins S, V, and G, and we see the different LEDs and resistors that are found on the PCB. The PCB contains text that identifies each of the components. You can work on your own to be able to determine which of the components correspond to the wiring diagram. For instance, R0 is a 1 kilo ohm resistor, and you can see it labeled on the board here, and the component is here. Let's take a closer look at the schematic. This schematic is with the momentary switch in the off position. VCC could be connected to 3.3 volts or 5 volts on the Raspberry Pi. For now, let's call it a 5 volts connected to the Raspberry Pi. So VCC provides 5 volts. 5 volts will be present on the R1 pin at this location. Some of the voltage will drop across R1, and we'll have the remaining voltage available for D0 LED. The remaining voltage will drop across D0, and then we will go to the ground circuit. Now let's take a look at the signal side. So notice that D1 is also connected to VCC. If we were to measure that at that point, we would see that there is 5 volts available. After D1, because there is no ground circuit, we would find another 5 volts, the same 5 volts at R0, and then after R0 would also be 5 volts. Because there's no current flowing through this circuit, the voltage is not dropping across each of these load devices. As a result of the voltage not dropping in the circuit, the signal voltage would read 5 volts. The computer would interpret this as a high on its input. So you can see why it really didn't matter if we had 3.3 volts or 5 volts. As long as it is that high, it becomes the input to the computer. Let's take a look at the schematic that has the button in the closed position. So there's nothing that changes on the D0 LED circuit. Everything remains the same, so the blue light or blue LED would be illuminated. The difference is that when I press the button, the yellow or orange LED illuminates D1. The reason that it illuminates is I'm now connecting the end of the D1 circuit to ground. That ground causes current, that connection to ground causes current to flow through the circuit, voltage dropping at D1 and R0, very similar to what they did on the other circuit. thereby leaving me with 0 volts at the end of R0, and my signal voltage becomes 0. The computer interprets this signal voltage of 0 as a low condition or off condition. Now that you've become familiar with how this button works and the schematics for both on and off, let's see how we can wire it up and read some of the voltages and see how the computer interprets it when we press the button.